In this lesson, we will be looking at multiplying monomials. So first of all, we need to remember what a monomial is. A monomial is either a number, a variable, a letter, or a product. Product means that you're multiplying variables together. So it's either a number, a variable, or a product of a number and one or more variables, and that makes a monomial. Mono, the prefix mono means one, which means it can only have one term in it. So basically it cannot be separated by addition or subtraction signs, and then it makes a monomial. If it's got an addition or subtraction sign in there, then it is not a monomial. So if we look at this, we will drag these to the right category. So first of all, we'll start with -5. -5 is just a number, but one number itself does make a monomial because it's one term. A, B, C to the 8th divided by 5th divided by 5. Those are all where you are doing a product of something. When you divide by 5, it's technically like multiplying by 1/5. So technically I'm multiplying 1/5 times A times B times C to the 8th. And as long as I'm multiplying every term, it is also a monomial. The next one, P plus Q, notice it's separated by an addition or subtraction sign. This is one term, it is a monomial, and this is one term, it is a monomial. But when I put them together with that addition sign in there, then it is no longer a monomial. This one would actually be a binomial because it has two terms to it. But for now, all you need to know is that it's not a monomial. In the next one, C divided by D, it looks like it is not a product, but remember when you divide by D, it is the same as multiplying by 1 over D. So this is really C times 1 over D, which is also a monomial. So I'll put that down here. And then X, of course, is just one term, and it is also a monomial. All right, we need to talk about doing some things with exponents now. So what we are going to look at now is numbers or terms, not necessarily numbers, terms, variables, raised to the 0 power. So basically you need to know that anything, absolutely any quantity, whether it's a number, whether it's got variables in it, whether it's a combination of numbers and variables, anything raised to the 0 power is 1. And that's because you need to think about this. Like if I take 2 to the 1, I get 2. If I take 2 squared, I would get 2 times 2. If I get 2 to the 3rd, I would get 2 times 2 times 2. So the only thing that makes sense is I need to figure out 2 to what number up here would give me 1 as an answer, and 2 to the 0 gives me 1. Okay? That's how it works. So any quantity to the 0 power would give me 1. Okay? So the answer, 8 to the 0 power, is 1. X to the 0 power, I know this is a variable, but again, anything raised to the 0 power is 1. The next one, I have the monomial 3x to the 5th, y to the 7th, but that whole quantity is still raised to the 0 power, and it is 1. Okay, now we are going to move on to multiplying two monomials together. So here I'm multiplying x to the 3rd and x to the 5th. Now, I'm going to do this the long way first so that you can kind of see how this rule works. But x to the 3rd we really know is x times x times x. And x to the 5th we really know is x times x times x times x times x. Well, if I'm multiplying that all together, then total I have 1, 2, 3, 4, 5, 6, 7, 8 x's. I can see that this is x to the 8th power. The shortcut to writing that out the long way would be figuring out that this is really x to the 3 plus 5 power. I have 3 x's here, and I have 5 x's here, and I can add them together to make 8 x's total, or x to the 8th power. So my answer is x to the 8th power here. Okay, here I've got some coefficients in front of those. So if I just had the x to the 4th and the x to the 5th, I think you could handle that. But now I've got the coefficients out in front, the 3 times the -6. So the part that's in red, you're going to handle just like normal. If I were to multiply 3 times negative 6, I would have negative 18. And then the green part, again, just so you can picture this, there's 1, 2, 3, 4 x's here, 1, 2, 3, 4, 5 x's here. Together, I have 9 x's total. Of course, the shortcut would be x to the 4 plus 5, which would be x to the 9th power. Okay? And then here I'm combining some variables to different variables. You can only add the exponents on variables that are the same base, okay? So I'm going to deal with the x's and the y's separately. These two have the same base. They both have a base of x. The x squared, of course, we know is x times x. The x to the 4th is x times x times x times x. So together I have 6 x's, x to the 6th power. And I don't expect you to write out all of those x's, but I just want you to know where it's coming from. Then I will deal with the y's, which have the same bases. Okay, so here I have 3 y's. And again, you don't need to write this part out for me, but just so you can picture it. Together, I have 3 y's here and 2 y's here, which means I have y to the 5th power total. Okay? All right, and now we've got all of that put together. So I'm first of all going to look at my coefficients out in front. Negative 3 times 4 we know makes 12. Then I will look at my x's. Now, it's not written up here, but there's assumed to be this 1 right there. So that's really x to the 1. So when I take x to the 1 times x to the 3, I'm going to add x to the 1 plus 3 to make that be x to the 4th. Okay, and then since my y's have a common base, I can multiply this and this, and I will add my exponents on my y's. So I have y to the 2 plus negative 1. Y to the 2 plus negative 1 makes y to the 1, which you don't actually technically really write. You don't want that 1 right there. Okay? So this actually is your grand final answer. And again, I got that by doing 12 times x to the 1 plus 3 times y to the 2 plus negative 1. Just so you know. Okay? And one more here. It's got a fraction with it, but we can handle this. So don't freak out about fractions. If I multiply negative 3 times 4, I have negative 12. And on the bottom, if I multiply 5 times 7, I have 35, and that does not reduce. Okay? Then I have x to the, again, there's a 1 right here, x to the 1 plus 5, which makes x to the 6th. And then I have y squared and y to the 1 power. So I have y to the 2 plus 1, which is y to the 3rd. And there you go.